Good day. As you can see, this is a reaction rate summary, so Chapter 12, Reaction Kinetics. And we start off by having you do that pseudo lab of magnesium and hydrochloric acid. Then we looked at some of the factors that affect reaction rate. A is nature of reactants, very vague. Often we're talking about metals as you go down the periodic table become more reactive, and nonmetals as you go down the table become less reactive. And that's due to their tendency to either gain or lose electrons. B, higher concentration, you get more frequent collisions and typically you get a higher reaction rate. C, increasing the temperature. Well, now you've increased the kinetic energy of the particles so they can transform that energy into potential, and that means more particles will be able to form the activated complex and you get a faster reaction rate. The general rule for a slow reaction is if you increase a slow reaction by 10 degrees, it doubles the reaction rate. Surface area applies to heterogeneous reactions. That's where you have more than one state. And in many cases, that's where we put a solid into a solution. And the solid surface area matters. So if you increase the surface area, you increase the reaction rate. And if it's decreased, then the reaction rate decreases as well. Catalysts we like to think of in two ways. One, it's a chemical that speeds up a chemical reaction without being used up. So it means it may participate in the reaction, but at the end you get it back. We also like to think of it in terms of potential energy diagrams, and what it does, it provides an alternate pathway with a lower activation energy, meaning the activated complex has a lower energy and is easier to form. And therefore more particles can form this activated complex and clear the hurdle. So all those things above that we've listed above apply to collision theory, and the idea is that if we're going to get a successful reaction, it requires an effective collision. That means enough energy and in many cases the right geometry, the right orientation of the molecules. We looked at P diagrams. And so things you should know are the energy of reactants, energy of products. The difference between those things is the enthalpy, or delta H. You should know that the activated complex will have higher energy, and it's at the peak on these graphs. You should know that when reactants are approaching each other, they're going to slow down. Their kinetic energy is converted into potential energy. And then once you have formed the activated complex and it's spilling forward into products, then that potential energy gets converted back to kinetic energy and move away rapidly. So, what are the things we have to talk about? Well, we've talked about catalysts earlier. Inhibitors, generally we like to think of those as tying up a chemical and therefore slowing down its ability to cause a reaction. We looked at reaction mechanisms, and the kind of questions you'll have there are given the steps or sub-steps of a reaction mechanism, you could figure out the overall reaction, or if I give you the overall reaction plus some of the steps, but I leave one blank, you could figure out the missing step. You must also be able to look at those and identify reactants, products, intermediates, and catalysts. So those are pretty important things to be able to deal with. Not mentioned here, we did spend a class on kinetic energy, a very different type of diagram. And the two things we tried to show you were what happens to the energy distribution of the particles if we increase the temperature or decrease it. How does that affect reaction rate? And what happens if we add a catalyst, and how does that affect reaction rate and why? So it is Chapter 12, so those are the pages. There's a summary, page 481, and there are some questions at the end of the chapter that may prove useful. There are exercise questions too, and those are worth looking at. We have a list of objectives for this section, so it means you should have these skills by the end of the unit, meaning by the time of the test, when that comes up very soon. So as you can see, that's our summary. For more details, go to specific notes on each topic.